Alright, so today we're going to move into the triangle midsegment theorem. So the first part would probably be knowing what a midsegment was. Hang on. There we go. So a midsegment is a segment that joins two midpoints. So notice on this triangle, X is a midpoint because you have two equal pieces. Z is a midpoint because you have two equal pieces. And Y is a midpoint. So these are all midpoints because you have two equal pieces. So notice we actually have three midsegments in this picture. XY is a midsegment because it's connecting two midpoints. YZ is a midsegment because it's connecting two midpoints. And XZ is a midsegment because it's connecting two midpoints. So midsegment is a segment that connects midpoints. So what is the midsegment theorem? The midsegment theorem says that the midsegment of a triangle is parallel, so that's actually really important, is parallel to a side of the triangle. So notice DE and AC, they're going to be parallel. And it's half the length of that side. So let's say this side was 10, my midsegment would just be 5. So it's also half the length. So they're parallel and the midsegment is half the length. So let's use it. So notice here, V is a midpoint and U is a midpoint. So VU is a midsegment. Well, that should be half of DF. So if half is 9, DF had to be 18. Right? All we had to do is 9 times 2. Again, whatever the side length is, the midsegment is half. Just double it to go the other way around. Next one, again, CD. C is a midpoint. D is a midpoint. So CD is a midsegment. It should be half the side length of the triangle. So if the triangle is 16, half of that would be 8. So my midsegment is 8. See all this lovely work? I want to see it. So whether you're multiplying by 2 or dividing by 2, I want to see that work. And here's why. So here we kind of went to equations real fast. Understand the concept, right? If we go back to that last problem, this was 8. You need 2 of those to equal the base, right? 8 and 8 make 16. Or 16, cut it in half, should equal 8. So either way, you need 2 of these to equal the side, or half the side can equal the midsegment. Either way, it works. So how would we translate that into this problem? Again, I would say I need 2 of these, right? You need 2 midsegments to equal the side of the triangle. So I need 2 of those 2x minus 3's to be able to equal that side length x plus 9. Just like if this was 16 and this was 8. 8 and 8 make 16. 2x minus 3 and 2x minus 3 make x plus 9. So let's distribute. 2 times 2x is 4x. 2 times negative 3 is negative 6. Still equal to x plus 9. I'm going to go ahead and subtract 1x from both sides. So we get 3x minus 6. And then I'm going to add 6 to both sides. So we've got 3x equals 15. And I'm going to divide both sides by 3 and get x equals 5. They did say solve for x, but definitely make sure you go back and read, because sometimes they'll ask you for QR or YW, and you would have to plug it back in. But this one does say solve for x, so we're done. Now sometimes the pictures look a lot more complicated. It doesn't mean that the problem's any harder. You just have to really hone in on what pieces you need. So let's look here. We're looking at JL. JL. Well, there's nothing here, but I see a mid-segment PN. So if this is 36, I need 2 of those to make JL. So you get 72. And then I always go back and erase and treat it like a whole new problem. It just, sometimes you have to really highlight the stuff you're working on. Next one is PM. PM. Well, that's a mid-segment. I see the base, or sorry, the side of the triangle right here. There's the parallel side. So 97 half. All right, 97 half of that would equal my mid-segment. So you really gotta, like I said, you gotta see which ones, if you gotta highlight it or make it stand out to you so you can see which pieces go together, because they marked a lot of information on here. So we get 48.5. Again, the math is not crazy, but I want to see your work just like I'm showing. And I'm going to go back and erase. And then we're going to do the last one. So this one has a degree. And this is where you might say, when do we use that the lines are parallel? Because you said it, but we've never used it. Here's where we use it. So if you're talking about angles, you have parallel lines. So I'm going to kind of highlight these a little bit. Parallel lines. You know, mid-segment is parallel to that side. Cut by a transversal. Sorry, my mouse is a little wiggly. So if this is 102, then the corresponding angle is 102. So we have angle MLK is 102 degrees because they're corresponding. So you will have to use those parallel lines cut by a transversal, but 9 times out of 10 it's corresponding or alternate interior. All right, last problem. We're going to do it the same way. So we want UW. All right, so we look here. And they tell me this is 7.4. Remember, all we have to do is cut it in half to get that mid-segment. So we take 7.4 and cut it in half, and we get 3.7. The next one says SVU. Now, I'm going to go ahead and leave these nice and highlighted for us. So I'm going to extend this out. Extend. Remember, these are parallel lines cut by a transversal. Alternate interior are equal. So angle SVU is 41 degrees. So 41 degrees because they were alternate interior angles. So it is, I mean, you do really have to highlight and draw those pictures out and see them. All right, that's your homework. Show all your work. Again, even if it's just dividing or multiplying by 2, I want to see it. Bye, guys.